Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we are going to continue doing practice questions for the National 4 Maths exam, but this time we're going to have a look at questions that involve us using a calculator. This means now that the sums that we want to calculate in order to solve problems or get a final answer would be a little bit too tricky to just do by ourselves or without using a calculator, so the calculator is going to give us practice using more complex sums. In this lesson we will go over 4 questions, and what I recommend you do is try the questions first by yourself after I've laid out the question for you, and then afterwards you can follow along and check if you got the right answer. So let's get started.
Ooh la la!
Okay, so let's have a look at question 1. We are told that the food brand Patchouli sauces are changing the shape of the labels of the jars from circles to squares, and we are told that the labels both have the same area, and that the area of the circle has a radius of 4.5 centimeters, and we've been asked to calculate the length of the new square label. So if we were to draw this out, we can see that the old label was a circle, and we're told that the radius of the circle was 4.5 centimeters, and here is the new label, which is square shape, and we're also told that the area of this label is equal to the area of this label. So if we are to write this out, we can say that the area of the circle, which I'm just going to call AC, is equal to AS, just for A squared. And because we're given the radius of this circle, that means that we can calculate the area of that as well. So we can say that the area of a circle, so AC, is equal to pi r squared, which is just the general equation for the area of a circle. And we know that pi just simplifies to 3.14, and the radius is 4.5, so it's going to be 4.5 squared, which is just 4.5 multiplied by 4.5. And if we put this into a calculator, we get an answer equal to 63.6, and the units, it would be centimeters squared, because the length is in centimeters, so that means that the area is going to be in centimeters squared. So now what we have here is the area of the first jar, so the area of the circle, but the question tells us that both of the labels have the same area, so that means the area of this is equal to the area inside the square. So that means that because AC is equal to AS, we can say that AS is also equal to 63.6 centimeters squared. So now we have the area of the square, but what we want to figure out is the length of the square. So how can we relate the length to the area? Well, we know that the area of a square, so AS, we know that's always equal to the length squared, because the one thing that's unique about a square is that all 4 lengths are equal. So in order to calculate the area, it's the length multiplied by the length, or just simply the length squared. So if AS is equal to L squared, that means we can say that L squared is equal to 63.6, because that was the area that we calculated. And then to calculate the length, because L squared is 63.6, what we can then do is take the square root of 63.6 to give us the length. And if we do this in our calculator, we should get an answer of approximately 8 centimeters, and that's to 1 decimal place. So the hardest part of this question, I would say, is the problem solving aspect of it. The maths is pretty simple, but the key thing is understanding the question and interpreting the key bits of information it gives us. The first thing is that we're told that the labels have the same area, so we can identify that this area is equal to this area, and all we really need to know is that the area of a circle is equal to pi r squared, and that the area of a square is equal to the length squared. And then we can just equate the area of the circle to the area of the square, because we can calculate the area of the circle because we already have the radius. We do that by pi times the radius squared, and once we do that, we can then equate the area to the length squared, and then just through simple maths we can take the square root of that area that we calculated, and that gave us our answer of 8.0 centimeters to 1 decimal place. Okay, let's take a look at this question. We are told that a surveyor has to calculate the height of a mobile phone mast, and from a point 20 metres from the base of the mast the angle of elevation to the top is 52 degrees, and we've been asked to calculate the height of the mast to 1 decimal place. So from the diagram we can interpret that this is the height we want to calculate, because we can see that's representing the mobile phone mast, and we're told also that a point 20 metres from the base, so assuming this is the base here and we go out 20 metres, we're told that the angle of elevation to the top is 52 degrees, so that's our angle right here. So again, a question like this involves problem solving, and we have to analyse the problem and think, what do we know, what is in our knowledge to help us solve a problem like this? Well, we can see that from the diagram, the shapes that this makes up, we can see that the cable and then the mast and the base, this forms the shape of a right angled triangle, with the right angle being indicated down the bottom here. And because we already have a side which is 20 metres at the base and an angle, that means that we can use trigonometry, because if we have a right angled triangle, one known side and one known angle, then we can use trigonometry to help us calculate the length of one other side. So the first step that I'm going to do in order to solve this problem is to label the names of the sides that make up this right angled triangle. For the side opposite the right angle, we know that it's always called the hypotenuse, so I'm just going to call that HYP. We know the side that's opposite the known angle, so here's the known angle, the side opposite that, we just simply call the opposite. And the last side, the side which is next to both the right angle and the known angle, is called the adjacent, which I'm just going to short to ADJ. The next thing that we have to do is to decide which trigonometry ratio that we want to use, and that begins by remembering SO, Ca, Toa, which represents the 3 trig ratios that can help us solve these type of problems. So how do we do this again? Well, we look to see what we know and what we want to figure out in terms of the sides. We are given the value of the adjacent, which was 20 metres, and we're asked to figure out the height, which in this case is the opposite, and we're not given any information on the hypotenuse, so that's not important to this problem. So we can see that we want the O and the A, the opposite and the adjacent, and we know that the last 2 letters within the ratios represent the different names of the sides that make up the triangle. And we can see that the TOA relationship contains both the opposite and the adjacent sides, so that is the ratio that we're going to use. And how do we write this out? Well, we can say that the tan of the angle, which I'm just going to call x degrees right now, is equal to the second over the third, which is the opposite, over the adjacent. And that's the same layout for any of the other 2 trig ratios as well. It's always the second divided by the third. And now we can fill in what we already know. So we know that the angle is equal to 52 degrees. We know that the opposite, that's what we want to figure out, which is the height, so I'm just going to call that h. And the adjacent was another piece of information that we were given, which was the base, and we were told that was equal to 20 metres. So now we have a formula that says the height divided by 20 is equal to the tan of 52 degrees. Now if we want to just calculate h by itself, we have to get rid of this 20 here on the bottom, and the way to do that would be to multiply both sides by 20, or we can just simply take the 20 over to the other side and multiply it by this, because if it's dividing on the bottom, when we take it over to the other side, it must be multiplied. So we can write that out like the following. We can say that h, the height, is equal to 20 multiplied by the tan of 52 degrees. And if we put this into our calculator, we should get an answer that's equal to 29.59883 and so on. But remember, the question asks us to calculate the height to 1 decimal place. So to do that, what we can do is highlight the first decimal place and then see the numbers after it, if that will make us round up or round down. And we can see that we have 988, which is quite a big number, and it makes it close to the next number, so that means that we're definitely going to round up, and the next number up from that is going to be 25.6, and the units is in metres, and that is to 1 decimal place. So again, a question like this involves us thinking a little and using our knowledge of problem solving. So first of all, we have to identify that we have a right angled triangle, and then we can see that we can use trig ratios or trigonometry in order to solve this problem, because we're giving one known side of the right angled triangle and one angle, and if we use the trig ratios, so SOHCAHTOA, then that allowed us to calculate the height, or just the other side of the right angled triangle. Okay, so question 3, we are told that at a World Athletic Championships, the mean time for the first semi-final of the 100 metre race was 9.98 seconds, and we're told that also for the second semi-final, the times in seconds were as follows. So here we have 1, 2, 3, 4, 5, 6, 7, 8 times that were recorded for the second semi-final, and the question asks us, was the mean time for the second semi-final better than the mean time for the first semi-final? So basically, for the 100 metre race event, we have two lots of semi-final times, and what we have to do is compare the first semi-final average time or mean time to the second semi-final mean time. And the question tells us that we already have the first mean time, which is 9.98 seconds, so we can just write that in. So that's the first one, and now what we have to do is figure out the second one and compare to see which time is better. Now, to calculate the mean time for the second semi-final, what we would have to do is add up all of these times together, so add all of these 8 times and then divide them by the amount of races that were recorded. So because there was 8 races or 8 runs that was recorded in total for the second semi-final, our sum for the mean time will be 10.21 plus 10.04 plus 9.92 plus 9.98 plus 10.04 plus 9.94 plus 9.9 plus 9.73, and then the sum of all this will be divided by 8. And then we can put this into our calculator and we should get an answer of 9.97 seconds. So that is the mean time or the average time that was recorded for the second semi-final. Now the question asks us, was the mean time for the second semi-final better than the first? And what do we mean by better? Well, if it's going to be a race, a better time would be a shorter time or a quicker time. And we can see that for the second semi-final, 9.97 is a smaller value than 9.98. So that would mean that for the second semi-final, this would be the better time. So for our answer, we could just simply say that yes, for the second semi-final, the time of 9.97 was better than the first semi-final. Okay, let's have a look at the fourth and final question of this lesson. We are told that on graph paper, we have to draw and label an x and y axes from -5 to 5. And then for part A, we have to plot the points P, Q and R. And for part B, we are told that PQRS is a square. And from this piece of information, we have to plot the position of S on our graph. Okay, so the first thing I'm going to do is plot the XY diagram on this little piece of graph paper that I have here. And I've indicated we want the scale to be from -5 to 5, both on the X and Y axes. And remember, we know that X is always horizontal, so the X axis is going to run this way. And the Y axis is vertical, so that's going to run up and down like we have here. So here we have our X axis, and here we have our Y axis. And now I'm just going to put in the scale. So beginning with the X axis, we know that this is the origin, and to the right of the origin we're positive, so we have 1, 2, 3, 4, 5. And as we work back the way, our negative from the origin, to the left we're going to have -1, -2, -3, -4 and -5. And then for the Y axis, moving up the way from the origin, we have positive, so 1, 2, 3, 4, 5. And then moving down from the origin, we get negative. So that would be -1, -2, -3, -4 and -5. So that is the XY diagram now complete. Now what I'm going to do is move over to part A, where we're asked to plot these points P, Q and R. So we know that when we want to plot coordinates, the first number indicates where the point lies on the x-axis, and the second number represents where the point lies on the y-axis. So for point P, that means that we move -3 in the x direction, but then +1 in the y direction, so this here would be our point P. For point Q, we move 1 in the x direction, but then 4 in the y direction. And for point R, we move 4 in the x direction, but 0 in the y direction. So that means that we just stay right here on the x-axis. So that's us now finished part A. But moving on to part B, we are told that PQRS is a square. So that would mean that if we have an extra point on this diagram and we labelled it S, if we joined all 4 of these points together, then that's going to form the shape of a square. And we've been asked to plot the position of S on our graph. Now when we do something like this, the key thing to consider is what makes a square a square, like what makes a square unique compared to other shapes, because we have to think about that in order to find out where the point is on the diagram. And obviously the thing about a square is that it has 4 sides, it has 4 corners, but the key thing is 4 equal sides that make up a square, and we can use that bit of knowledge in order to figure out where S is going to be. Now because the sides in a square are all equal, that would mean that this side here, so PQ, is going to be equal to the side RS, wherever S is going to be. So that means we know that S is going to be in this vicinity right here. But to figure out exactly where it's going to be, what we can do is figure out the relationship between points P and Q, because the distance away between these 2 points is going to be the same for RS. So what I'm going to do now is, by measuring both the vertical distance and horizontal distance between the points P and Q, I can figure this out and do the exact same to figure out the distance between points R and S. So beginning with the vertical, we can see that if we look at point Q, if we move 3 down, that gets us in line with point P, so the vertical distance would be 3. And then the horizontal distance is across, so that's going to be 1, 2, 3, 4 boxes to get to P for the horizontal distance. And now since we know that, we can do the exact same from R to get to point S, this imaginary point S. So if we move 3 down from point R, we have 1, 2, 3. And then if we move 4 across, 1, 2, 3, 4. This gives us this point right here, so I'm just going to mark this in right now. So now our 4th point S gives us coordinates of, well, what do we move in the x direction? We don't move anything, we stay on the y-axis, so the x is 0. But we move 1, 2, minus 3 down, so that means the coordinates of this new point S is going to be 0, minus 3. And then we can see that because we plotted the point C correctly, these 4 points can be joined together to form a square. And just a reminder, what we did was first of all figure out the horizontal and vertical distance between points P and Q. And because the shape was a square, the distance between P and Q is going to be the exact same distance for R and S. So we just figured out these distances and said it was the exact same to get the point S, this distance over here. So this is the end of this lesson, and I hope this video has been helpful to you, and obviously I hope that you got most of your answers correct in this video. But if you have any questions on it, just drop a comment down below and I'll get back to you as soon as possible. And if the video has been helpful to you, be sure and give it a thumbs up. And if you'd like to see more content like this, subscribe to our channel or head over to our website at penguin-learning.com. Thanks again for watching, and as always, I'll see you in the next video.